Hello friends, my name is Konstantin, I am from Moscow, Russia, and today we'll perform the talk about web audio services development. Actually, this is mostly about creating, configuring, and deploying web audio services software with Raku. But in the beginning of this talk, I would like to introduce myself to say a few words about me. My general interests are related to real-time programming, multi-threaded systems, low-level programming like drivers, real-time operating systems, components, and whatever. I'm working on a critical software verification, test automation, and modeling. On the other hand, I am a Ethereum enthusiast. Not actually a cryptocurrency holder, but I think blockchain technology researcher and developer. Over 5 years on this way, I have an experience with the different Ethereum-related features like centralized projects, DeFi applications, smart contracts, node and network setup and deployment as well. Also, I have involved into the Raku ecosystem. I'm a maintainer and contributor of a few Raku modules like router write, LZV, Revolunet, Net Ethereum, and Fakes. Previously taken part in a few Perl workshops and conferences. Maybe you know me, maybe we have met anywhere. So that's okay, and the summary is over. I think we should start with my presentation. I will share my screen. Okay, it's the first slide, a title. The talk topic is the programming digital audio server backend with Raku. So actually, it's about how to build web audio service with Raku as main programming language. Let's start. In the beginning, I would like to discuss the subjective opinion about what are the web audio services now. The COVID-19 reality gave them a new life, I think. When we have such things like self-isolation, social distances, lockdowns, people prefer to stay at home, and it's good. We should keep in mind that if they have been involved into collective creativity process before the pandemic, now they are online and want to continue work from home, continue to do usual record sessions, for example, rehearsals, whatever, from their laptops, tablets, and phones. In this reality, we have a big interest for online web services for creativity, especially services for musicians, dappers, actors, and other creative people. Generic audio services are working on server or cloud, network of servers, I mean, and provides a set of tools like artificial intelligence composers, stylistic classifiers, plagiarism scanners, and content reviewers. Core features are sound processing or synthesizing on server and client side. Today we have more or less rich audio support for clients, I mean on client side in the browsers. It's web audio IP technology, JavaScript libraries, modern JavaScript libraries like Tone.js and Wave.js. And what to choose? To process sound on client or to process sound on the server side? And to resolve this question, we should consider cases. Processing on client is good if your web servers work on a single peer-to-peer connection model. I mean, of course, you can have many clients online, and we suppose that all of them are independent and do not communicate to each other. In this case, all audio processing should be performed in the browser, should be performed on the client side. But server-side processing is good for the next cases. For example, you have a proprietary algorithms which you don't want to share with someone. The next case, you have a many-to-many client communication model. For example, you need to mix audio streams from the few clients and broadcast it to many listeners. In this case, you need to have a central server that will perform these procedures. And the third case is you have specific devices attached to a servers. The basic is digital sound processors or some hardware solvers for specific algorithms. For example, Fourier solver or transition function solver or something other. Also, you should keep in mind the client-side processing is good for decentralized tasks, and server-side is perfect for cases with arbitrary control, with cases where you need a central server. Okay, let's, in this talk, we are considering the server-side processing as well. And we should know what specific are on server-side. First, and the basic is the main operating system on server is Linux. If you have experience with audio processing, with audio programming, you know Linux is one of the mostly unsupported platforms. The next thing you should keep in mind is there is no graphical interface on server. We have no any dialects, windows, widgets, and so on. And the last thing, valuable thing is that we have only TCP transport on server. We should pass all our traffic through the HTTP and HTTPS. That's a thing we should keep in mind. But the good is that the software on server for audio processing is much more flexible. As I have said, on the client, we use browser features or JS libraries, JavaScript libraries based on these features. But on server side, we could use anything. We could use native libraries. We could perform driver calls to attached server devices. And we actually on server have much more abilities to cover our requirements. So here I will introduce a new term. It's a headless audio backend, the generic software, the generic server-side software. Also want to fix your attention, we can combine the server-side and client-side processing. This is a very positive approach and something we should do something on client and do something on server. And we will consider these cases in this talk. Okay, what actually is a headless audio backend? It has at least two layers. It's a generic, it's a main layers. It's a client service, not a service like a Linux service or Windows service. It's some kind of software that serves the client, And the next thing is the audio engine. As I said, client service is something like a front line of backend. It speaks with browsers and performs full stack of client management, audio authorization, configuration, streaming, and whatever. And the audio engine is the heart of a server-side software and performs all digital signal processing features. It can be implemented as an active or passive service, and we will consider these cases below. The new term is ABC schema. On the previous slide, we have spoken about two components. It's client servers and audio engine. But the next thing is to consider the more complicated view of headless backend. We adding the new entity, it's balancer. This software entity is between the audio engine and client service. The main goal of balancer is to reduce the load of audio engine. In some cases, we do not need to use balancer. For example, in simple services where there are only one audio engine. But if you have a cloud processing service, for example, network of audio engines, we need a balancer. We have to use a balancer. And this will manage, and in this case, balancer will manage tasks inside our network. It should distribute tasks over the audio engines. What actually is the audio engine? I will consider passive audio engine as a shared library in this talk. This shared library will have a set of audio processing features like a fast Fourier transform algorithm or inverse fast Fourier transform algorithms, resemble function, normalize function, transfer function, spectrogram creator, and different others. If it has specific devices connected to our server, Audioengine should have a layer with driver calls or inline assembler. Also, I should mention that audio engines are traditionally written in high-performance languages like C and C++. What is balancer? Let's consider the more details about the balancer. We will start with cases. First case, it's, for example, we have single audio engine. Actually, in this case, we don't need the balancer. We have some profit if we have a multi-core platform. Balancer can execute runners in parallel processes and on independent CPU cores. Here will be a little profit. The next case, we have a few audio engines on independent servers or on independent virtual environments. Balancer should manage the task over the servers and run them on different cores if it's possible. It's the basic use of balancer. And the third case is when we have special hardware attached to our server for specific task. I mean, here the balancer should understand what tasks could be processed on this device, communicate with this device, and push the task on it. For example, if we have a hardware solver for Fourier transform, balancer understands, okay, this task have Fourier transform inside and should be pushed and should be solved on the hardware devices. So it will run a stack of driver calls, push tasks to the device, and fetch the results. So this is the main function, the main functionality of the balancer. So all these cases suppose the balancer with functionality of task manager. I mean, each would has implementation of policies, of specific policies, scheduling, task fetching, or cancellations. And what about the client service or client controller? Actually, I support the regular content management system there. It should allow non-technical users to communicate with audio engine features. And the specific features of content management systems are, first of all, it should has two layers, presentation and administration layers. Of course, one area of our web service is private and the other should be a public one. CMS should support templating. Of course, it's a basic thing. It should be scalable or expandable. And in this presentation, we will show how it really works and how we can add new features in our CMS via modules or add-ons. It should have rich editing tools, and we do not need to mark up or write raw HTML. All we have is what you see is what you get editing tools. It's very similar to Word or another high-level text editing tools, like the text editing instruments. And of course, our CMS should manage workflow. I mean, access levels, roles, credential storage management, and similar thing. Okay, here's a new one iteration with the terms. Previously, we've spoken about the ABC, I mean, Audioengine, balancer control schema. And now we should define the GRP. What is GRP? ABC reflects to GRP, because when we consider an ABC model, we are talking about backend software components. But GRP just defines the software. Software is complex as a programming tools, libraries, and frameworks. So GRP, audio processing backend, is defined as, firstly, JUICE framework. It's fast, well-documented, noob-friendly audio processing framework written in C++ and C. The next thing is Raku. This is a quote from Raku website. Raku is feature-rich programming language made for at least the next 100 of years. Absolutely agree. And the third thing is Fakes. Fakes is content management system with data storing on blockchain, on Ethereum blockchain, written in Raku. Okay, let's get an answers for the question why we should use JUICE. Basically, JUICE has a lot of components and tools related to audio processing. Also, the philosophy of JUICE is all in one. I mean, if you're using this framework in your application, you get everything you need to build your application. And not actually the things related to digital sound processing, digital signal processing. There are a lot of helper classes and components like JSON, cryptography, OpenGL, graphical user interface, and other handy things. Also, we can create console application with JUICE or shared library as well. That's very important in relation to our talk because we use web service, we use passive web service based on shared library. But the bet is that JUICE has license restrictions. If you use these frameworks in the commercial purposes, you should pay to JUICE guys. So keep in mind this thing when you are creating a roadmap of your startup or starting the development of some web service. Why Raku? The next question. Why Raku? The answer, it's made for at least next 100 years. But seriously, Raku has very intuitive and clear native call layer for integration with third-party libraries or application. I have experience with Swig, nice adapter for Perl 5, and JNI, its Java native interface, also supports calling libraries in other languages from Java. And well, my opinion is Raku has one of the simplest implementation. C language is quite nice supported by Raku native call, but C++ is marked like experimental and not well tested and developed. But we use it. We use Raku for adapter for C++ libraries, and there is a great how-to by Andrew sheet of how to with explanation how to use native calls to C++ library. Link is provided on the slide, and you can browse it, for example, later, see what happened there. Okay. Why fakes? As I like to say, fakes is the first CMS in the world with data storing on blockchain and written in Raku. Haha. Yeah, that's true. And this is the thing why it should be used in audio web services. In this industry, copyright-related questions are very important, and blockchain technology provides mechanism to store tamper-proof data and to guarantee that data is kept unchanged, uncorrupted, and validated. Simple example. The band is recording the track online, and during one of the record sessions, someone from the members proposes music phrase or riff. We can store this event as metadata on blockchain, and in the future it could be used to prove the author rights, or could be used in copyright disputes. Also, fakes now at the beta release. It was announced on 25th January, and the basic question, why fakes? I answer, why not? Let's stop on the integration point. In gRPC concept, Raku is the glue for audio server backend components. Also, we can consider this language as a tool for creating high-level adapters for JUICE Audioengine. I mean shared library in this case. The front server backend component is fakes, I mean client service. When Audioengine adapter connects to fakes as add-on or external module, the fakes add-ons or modules should be implemented according to the specific guidelines. Add-ons are the regular Raku modules. It's a simple Raku module, but they should be set up in a fakes global configuration file. I will speak about this later. If we need to integrate some Audioengine features to our backend, we just write a new module covering required Audioengine API and install it on servers, and it should work. Okay, now we are starting with a practice section. As I have mentioned above, our web audio service is passive. We have no persistent workers or any active entities. We use shared library as well. The basic approach is to call single library API on request. One API, one request, one API call. But if we need to batch or loop over APIs, we should. For first, extend our library with a accumulator function which performs additional logic. I mean loop or batch. Or we do loop or batch at takes adapter module, I mean inside the Raku module, or in browser, chain of the client requests. What to choose? Should see the cases, but it usually relies on your server performance, the first thing, bandwidth, and current web service load. So maybe there are some cases where you should combine these methods. I mean, a chain of request and accumulator function on the backend. It should be possible. I think it's real. Okay. Once more, we use Juice as a shared library. Juice has its own project manager. It's called Producer. It can create projects of different types. For example, standalone application, audio plugin, console application, library, and whatever. For Juice 4, it's a quite older version or a lower version. Unfortunately, there is no option to create shared libraries. So in these cases, we need to patch console. We need to create console application and patch its makefile. I'm presenting the link to the repository where this work is done. So if you use older Juice frameworks, Juice frameworks version, I think you need to check this link. But the better way is to use the latest version, of course. In Juice 6, the current version, there is a feature to create the shared library, and there is a build option for this. So all you need is to implement your API and run make utility. Very simple. Here is the window of Producer. We see the screenshot when you are creating the new project. You just select dynamic library. It's selected on this window, on this screenshot, and create library and go on. Very trivial. Now we will consider the example of a simple shared library. I will show how to create a very simple demo library and perform its API call from Raku script. For this case, I will create a simple library with an only API call. One API call, I mean. The source code on the slide. We have Juice shared call. Juice shared is a function name that returns integer value, has no inputs, and arguments, and prints current Juice version, Juice framework version. It's taken from Juice headers. So all we need to create a dynamic library project. All we need is to create dynamic library project, add one source file with this code and patch make file, because by default, Juice hides the user APIs. You see on the slide, we have a visibility hidden flag. It's set by default. So I just removed this flag from makefile manually, but you could comment or apply some settings inside the Producer. Next, we have to run make, and voila, our shared library is cooked. Also simple. And what about Raku native call? As I have mentioned above, we have a great article by Andrew Shitov, how to call C, C++ for Tran from Raku. And on the slide, I will do quick explanation. For more details, you should follow the link to the original article. In case of C++, we have to get correct symbol name of our function from shared library symbol table. We use nm utility, command line utility, with a grep in pipeline. It will output this command line is given on the slide and have a pink background. You should see it. And it will output the line with address and complex name. You look to the slide and we will see here is the address, T symbol, T character, and here's the complex name. Let's see what is the complex name. Underscore NZ are to avoid the user namespace complex. 11 is the length of the function name. Yes, really. Just share has 11 chars. And V is as the postfix shows, and V is a postfix. It shows how that we have void on the place of parameters. In other words, we have no parameter and we have a void as a on the parameter in the function. Okay, what is Raku test script for this? The complex symbol name that we are considering on the previous slide, we should use that name in our Raku code. I have a sample called just Raku script. The name is with the pink background on the slide. And it has a trivial code. First, we declaring using of native call. Next, we define Raku subroutine with name just shared. As a native, we have native statement, is native statement. We give the path to our shared library to the statement. And also we have is symbol statement, which fetched from the library with a name which fetched from the library symbol table, also was shown on the previous slide. And the third thing, we just need to call the Raku subroutine. It will work. Our script will output the version of Juice framework. Let's check. We see I am a Juice 545 shared library, and this is exactly we have code in our C++ code here. Very trivial. But of course, there are a few tricks, and all of them are related to the return values and function arguments. Okay, let's see. In this talk, I will a few times I have spoken about web audio services. In this talk, we're exactly speaking about the frequency visualizer or frequency analyzer, as in some places I name it with different names. But this web service provides the next basic functions. First one is resampling. We need to resample from different sample rates to the etalon one. The next thing, we need to write down spectrogram. Also, we need to mix audio channels, do Fourier transforms, analyze the data after transforming, and save, analyze the data in JSON. On this slide, every functionality or every feature has a link to original Juice documentation, so you could check what component, what class is used for some features. Also, we have I provide the link to MATLAB model, and you can check what analysis I done on inside my frequency visualizer. So if you're familiar with the MATLAB or Octave, check the link. Here's a M script that could be easily run on MATLAB, and you would understand it, debug it, whatever. And here is the window web view of a frequency visualizer web service. It works directly in browser. What steps should user perform to see this window? First of all, we need to upload the audio file. After successful upload, processing handle is run and results data are available online. Here you see two types of spectrograms, one with the more accurate frequency analysis and power visualization, the red one. Also, you see the plot with frequency curves. It's the work on specific processing algorithm. It's the work of specific processing algorithm. But as you see, there are many correlations between the plot and waveform. And well, it's some kind of proof that algorithm works fine and we have true data, no any fakes here. Let's speak about Raku adapter module. It has two basic requirements. First, it should be installed via ZEF package manager. And the next, of course, it should cover all Audioengine APIs. Current APIs are presented on the slide, and we'll go through them. And they are implemented exactly as I have shown above, I mean native call. But we should keep an eye on a pointer type of return values and arguments. Okay, we need to save spectrogram, as I said. Save spectrogram API call is the simplest one. It has only argument as a file name with a string type and returns integer as a bool type. Does spectrogram processed and saved, or we have an error. Also, we need to resample. We have the resampling API call. If we got file with a bigger or lower sample rate, we need to normalize it. It's more complicated. We have two arguments. First, it's an integer sample rate and a pointer to buffer to resampling. Also, we have a buffer as a return, we have a reference to buffer as a return value. Do mixing. We need to mix left and right channels. So we don't use separate channel analysis, but with mixing, we keep some channel specific frequencies. We do not lose anything specific data. This call is similar to do resampling, but it has only argument as a reference to the buffer to mix and returns a reference to mixed buffer. Do FFT, it's a simple Fourier algorithm transform. Also, we have a buffer like as an input argument and return the reference to buffer as a return value. And the last call is do analysis. It also takes only argument as a pointer to buffer, FFT transformed buffer, and returns a pointer to string with the JSON data, with the results in JSON. Okay, let's speak about integration. I should say a few words how FX works with add-ons. First, add-ons are regular Raku modules. It's one point. And the second, add-ons have a strict development guidelines. FX is based on hybrid CMS concepts. What is this? On one hand, we have legacy CMS approach for page templating output. But on the other hand, we use REST API for page content rendering. I mean, when we are generating the main page from template, on the place of content, we have a JavaScript call, another JavaScript call to backend, which retrieves the content from our CMS. And this is the case of headless CMS. So it should be followed during modular implementation or during the modular development, because some modular methods are CMS independent and others will be used by CMS. Sample add-on source code is presented via the links. You could inspect it. But more info about add-ons and modules development for FX, you can find our wiki pages. Please check out. What is modular configuration? The basic config supposes roles. We need to set up at least 3 roles. First, for file upload form. Second, for upload files list. And the third is for file details. This is actually a frequency visualizer page that we have considered a few slides before with spectrograms and plots. I should mention that we use Raku, that we use row-to-write modular as a primary router. It has good performance and provides powerful tools for routing annotations. Check Module Wiki for details. Link also is attached at the slide, to the slide. We store the roads in JSON. As I say, roads are configurable. We store roads in JSON configuration as a JSON configuration. Here is a sample one with three roads that we discussed on the previous slide. Every road has own path. It's like an URL and own handlers. Default handler for each router is handler for page, for entire page, I mean. And API handler is a handler for content. As I said before, we're fetching content via additional API call. Default handler renders the page from template with JS code that performs REST API request for content. This request is processed by API road and API handler as well. That's a summary. Let's speak a few words about the module structure. This slide, just a summary, but the important details in our module. Private methods should be related to just Audioengine, and public methods are related on fakes. Also, we have spoken that we should cover all just audio backend IPs, and also we should follow fakes CMS integration guidelines while during the modular development. When our module is implemented and installed via Zeph, it's available to use it from fakes, but we need to say to fakes, please pick it up. This is done through the configuration file, generic configuration file. All we need is to add key values, new key values to the installed section, or to installed collection. As you see, we have frec_viz key and fake signal frequency visualizer like a class as value for this key. The public methods prototypes should look like. Default road methods have two arguments, tick and match. Tick is a counter of FCGI calls. It's used because we have FCGI as a primary technology to work with within fakes. And match is containing road matching details. For example, you fetching some IDs, page names from this structure. It's a simple hash in terms of Raku types. And API road methods have much more arguments. Tick and match considered above. So let's speak about others. Road path is a simple string, very similar to URL. And share object argument contains references to fakes inner helper objects. I should say fakes have many helper objects that are available to user, I mean to caller modules. For example, JSON helper object, FCGI helper object. Also, we have blockchain helper object. So please check our wiki pages to understand what share object you can use inside your module. And I should say it works. Yes. The live frequency visualizer is available now. The slide has all related links. Please check them out. First one, it's frequency analyzer servers, is deployed on NeoRX site. The second link, it's analysis algorithms that are stored in separate weapon. You see MATLAB model there, MATLAB Octavia model there, some tickets on the algorithm validation and algorithms proposals. The third link is a link to Juice Workaround repository. Also, is a group of repositories. There are a few ones. For example, we consider it one repository where we are patching make files for older juice versions to create a shared library from the console application. So check it out. And the last link, it's very interesting. You should check it because there is a fakes add-on integration thread. There are a few tricky equations I mentioned there. And if you're interested in how to implement modules for fakes, you instantly should check it out. Okay, we're at least at the end, and we'll speak about the perspective of this project. In 2019, I was at Audio Developers Conference, and there was a great workshop about writing application with Juice backend and JavaScript frontend. The idea was to use headless Juice backend application, and use JavaScript written graphical user interface with React and Electron, like a separate application, like a separate web application. In that case, Juice backend has no GUI, but performs sound processing and sound playing. It's interesting because GUI is platform was in this case GUI was platform independent. It looks the same on iOS, Android, Windows, and other systems. But as you know, basically graphical user interface can differs from one operating system or one browser to another. So my goal is to take this example, to take the example considered during this workshop and put the fakes in the middle. And also the interesting and very tricky thing is to perform Juice not playing sound, but streaming it to client. So client, I mean browser. So we need fakes to take stream from the audio engine, Juice audio engine, and pass it or proxy it to the browser. Also, interesting feature is interesting for me seems to save all events like command collections from remote GUI or some hashes from audio stream. I mean pauses. I mean different things that we could maybe breakpoints on the stream, maybe some timestamps from the stream to blockchain. And it will be very interesting, in fact, of the using blockchain and using this technology like a additional logger for our performance, for our running, for our Juice backend running. So this work in progress. I think I will get new results this summer, and very, very, very hope to be at Audio Developer Conference for this year with a talk about this system, this web service. Well, I should perform the open call. Yes, I want to invite you all to Juice and Raku and Fakes development process. Here are the links, and of course, forks, pull requests, code reviews are very welcome. If you like any ideas from this or concepts from this talk, let's get in touch. And of course, you could help me to keep this work on via donations. So this red panel, it's exactly about this. So if you can, please donate. So that's the end. I would like to thank Perl Developer Rooms organization. Sorry, it's I say hello to JJ and Stuart. I'm proud to perform this talk and I'm happy to be the part of the FOSDEM 21. So thank you for your attention. Please go on if you have any question.